Hello everyone. Myself Dr. Kouser, Assistant Professor of Computer Science. Welcome you all to session 5 of System Software and Operating Systems course. The session 5 is on the databases that are used in assemblers, the data structures that are necessary in the pass 1 and pass 2 of assemblers, and we learn in detail the working of pass 1 of assembler in this session. In the previous session we have learnt about assembly level language and various parts of the assembly level language with examples. So before we move on to the database and data structures part, let us have a recap of general working of assemblers. An assembler works by assembling and converting the source code of assembly language into object code or object file that constitutes a stream of zeros and ones of the machine code, which are then directly executable by the processor. Simply we can say that assembler is a system software which converts the assembly level language or the symbolic language, also called the mnemonics, into its equivalent binary code or also called the machine code. So the assembly level language that is input here is nothing but the source code, which is then converted to the target or the object code, which is the machine code. So during this process, the assembler comes into picture, and this assembler makes use of various databases as well as data structures that help assembler in performing the conversion. Coming to the assembler functions, I have listed a few functions here. Whenever an assembly level language is input, we need to perform various conversions of the mnemonic or symbolic operation codes to equivalent machine language. Likewise, we should also convert the operands that come in the instructions, symbolic instructions, to its equivalent machine language, and also the data constant should be converted to its equivalent machine language. Once all these conversions are performed, it should build the machine instructions into a proper format, which can then be used by the loader for the next process. It should also write the object program and the assembly listing. So assemblers are classified based on the number of times it takes them to read the source code before translating it. There are both single pass as well as multi-pass assemblers. So coming to the assembler directives part, these assembler directives are nothing but the pseudo instructions. They provide instruction to the assembler itself. Also, you should remember that these directives or the pseudo instructions are not translated into equivalent machine operation codes. For example, let us see some assembler directives like start, end. Start, it specifies the name and starting address of the program. End, this is signifies the end of the source program. All these directives or pseudo instructions are not translated into equivalent machine operations. We also have some instructions like the byte, word, RESP, RESW, RESB to reserve bytes, and RESW is to reserve words. End of record, which signifies the end of a particular instruction set, and also an end of file, etc. We should also know something about a forward reference problem. So use of an identifier before its declaration sometimes results in an error. This is called forward reference problem. Therefore, assembler scans the source code twice, that is pass 1 as well as pass 2, to overcome this forward reference problem. Now let's see what are the different activities that happen in the two passes of the assemblers. The pass 1 function is to basically define the symbols as well as literals. During this phase, it assigns the address to all statements in the program. Then it saves the addresses that are assigned to all labels, which can then be used by pass 2. It also performs some assembler directives, including those for address assignment, such as byte and RESW instructions. So this is the basic working of the pass 1, where its function is to define symbols and literals. Later in pass 2, the major work that is done in the pass 2 is It assembles the instructions that are given by pass 1, and then it generates the target program or the object program, which is the equivalent machine level language program. During this pass 2, in the first step it assembles the instructions, which generates opcode and lookup addresses. Then it generates data values defined by byte, word, etc. It performs the processing of assembler directives which are not done during the pass 1. Then it writes the object program and also performs the assembly listing. So these are the important steps which occur during the pass 1 and pass 2 of assemblers. So the important thing that you have to keep in mind is during the pass 1, the symbols and literals are defined, and various addresses are stored which can then be later used by pass 2. And in pass 2, the assembler assembles all the instructions and then generates the equivalent target code. So moving on to the data structures or databases which are used by assemblers both in pass 1 as well as pass 2. The first important data structure or the database that is used is the OpTab. The full form of this is Operation Code Table or Machine Operation Table, also called MOT. Sometimes we use the symbols like mod get 1, mod get 2. Mod get 1 is used in pass 1. When it is 2, it is referring to the machine operation table that is used in the pass 2. So let us see what this OpTab or mod get table is. It is used to look up mnemonic operation codes and then translates them to their machine language equivalents. The use of this OpTab in pass 1 is the OpTab is used to look up and validate the operation code in the source program in pass 1, whereas in pass 2 it is used to translate the operation codes to equivalent machine language. In pass 2, we take the information from the OpTab to know which instruction format is to use in the assembling and the instruction process, assembling the particular instruction. The next database is the SymTab, which is symbol table, also called EST in short. This symbol table includes the name and value for each label in the source program together with the flags to indicate the error conditions. Example, if a symbol is defined in 2 different places, then the error flag should be set. During pass 1, the symbol table, what it does is the labels are entered into the symbol table along with their assigned address values as they are encountered. All these symbol address values should get resolved at the pass 1 itself. There should not be any conflicts within those symbol addresses. So during the pass 2, symbols used as operands are looked up in the symbol table to obtain the address value to be inserted in the assembled instruction. So the same table is used for 2 different purposes. In pass 1, all it does is all the particular labels which are entered into the symbol table along with their assigned address values should be updated as they are encountered. And during the pass 2, symbols used as operands are looked up in the symbol table to obtain the address value to be inserted in the assembled instructions. So the next database that is used is the LC, also called LOCCTR, that is a location counter. It is an important variable which helps in the assignment of addresses. This location counter is initialized always to the beginning address mentioned in the start statement of the program. After each statement is processed, the length of this assembled instruction is added to the location counter. That is, this location counter gets added with the length of the instruction that is already processed. So then this location counter is pointing to the next instruction. Whenever a label is encountered in an instruction, the location counter value gives the address that has to be associated with that particular label. It is all the addresses are counted in bytes. So the next database that is used is the literal table. It is a lookup table used to hold literals during the assembly and execution. The literal table holds the literals during the assembly as well as the execution process. And the next database is the POT, also called the pseudo operation table. Here, as the name suggests, so this table indicates symbolic, mnemonic, and actions that need to be taken for each pseudo operation in the pass 1. In this diagram, we can see the various databases that are used by the pass 1 and pass 2 of assemblers. Here from the Kouser.K, once the input comes to pass 1 of assembler, here this you can see the arrows that come from various databases like location counter, the pot, mot, symbol table, literal table. These are the 5 different databases that are required by the pass 1 of assemblers. This whatever the output of the pass 1 is, then that is copied to the source deck, which is then input to the pass 2 of assemblers. And we see that even in the pass 2, this there are some common databases like the mot, st, as well as the literal table. And along with that, the pass 2 makes use of some additional databases like the base table instruction, inst instruction. Then it also makes use of some data structures like the punch card, print line, and location counter is used in both the places, as pass 1 as well as pass 2, and it needs additional databases for listing. Then the output of this pass 2 is moved to a database called the object deck. Now that we have understood in brief about the various databases that are used in pass 1 and pass 2 of assemblers, let us move to the algorithm and flowchart part of the pass 1 of assemblers. The first step of the pass 1 of assembler is the location counter initially points the first location of the program, and then the source program is read. In the next step, the label field. We know that the assembly level language consists of 3 parts: the label part, followed by the instruction part, and finally the comment part. Here the label field of source statement is examined for the presence of symbol. Okay, if there is a label, the symbol table is updated, that is this particular symbol is updated in the symbol table along with the value of the location counter. Then the operation code field is examined to determine if it is a pseudo op. If it is not a pseudo op, then the table of mod, that is the machine operation table, is searched to find a match for the source statement's opcode field. If match is there, you should get the length of the instruction, and then the operand field is scanned for the presence of a literal. If you find a new literal, then that should be entered in the literal table. Finally, the current value of the location counter is incremented by the length of the instruction that has been executed, and then you should copy the source code and then it is saved for further use by the pass 2. So these above sequence of instructions, that is steps from step 1 to step 9, should be repeated for each instruction that is encountered during the pass 1 of the assembler phase. The same algorithm can be represented in the flowchart below. Here you have to initialize whenever there is a symbolic code in front of you. Maybe it consists of say 2 or 3 instructions. Then first it goes to the first instruction or the line of code, symbolic code. Then it is initialized. Then it has to be then read. Once it is read, you have to check whether it is a label. So if it is a label, then it moves to the right hand part of the data structures. The decision has to be made that it is a label. Then this particular label should be stored in the symbol table along with the location counter value. If it is not a label, then it has to go search the potget, that is a pseudo operation table. So if it is found in the pseudo operation table, then it has to check if it is a pseudo instruction, what kind of a pseudo instruction that is. In the previous session we have learnt the various pseudo instructions that can occur during the assembler phase. So if the kind of pseudo instruction is end, then it has to stop the pass 1 and go to pass 2. So if it is not an n type of pseudo instruction, then it will go to DS and DC, which determines the length of the data space required for that particular pseudo instruction. The various pseudo instruction that could be encountered, like DEC of n, HEX of n, etc. Suppose you don't find that particular label or the instruction in the pseudo operation table, then it will go further search it in the MOT, that is the machine operation table, also called MOT-GET. So once it is found in the MOT instruction, the instruction part is found in the MOT-GET, then you should get the length of that instruction, then you should process the various literals that are encountered, and that will be stored in the LITSTO. All the symbols will be stored in the STSTO, that is storage of symbol table storage, and this is the literal storage. So once the literals are processed, then you should as usual update the location counter. So once the location counter is updated, then it will move back to the next instruction, then read it, and then it should repeat all the steps that I explained. So with this, we come to this end of this session 5, where we learnt about various data structures, databases that are required for pass 1 and pass 2 of assemblers, and also we learnt in detail the algorithm and flowchart of pass 1 of assemblers. Thank you all for your patient listening. In the next session, we will be discussing the pass 2 of assemblers, not the databases and data structures, but we will be discussing only the flowchart and the algorithm of pass 2 of assemblers.